So today we are going to discuss about unsupervised learning algorithms and supervised learning algorithms. Okay. Yeah. Let me share my screen. 1 second. Is my screen is visible? Online. So today we are going to discuss about the unsupervised learning algorithms. Okay. Unsupervised learning algorithms. In this unsupervised learning algorithm, it is a unlabeled data. It is a unlabeled data. That means we don't have any outputs. Don't have any outputs. So we don't have any outputs. Just we only have a independent data, not a dependent KLF. We don't have any dependent column in this unsupervised data. That is unlabeled data. Okay. In that so unsupervised learning, first algorithm is K-means cluster. First algorithm is K-means cluster. First algorithm is K-means cluster. Today we are going to discuss about K-means cluster. How exactly the K-means clusters works. Okay. Today we are going to discuss about the K-means cluster. For example, so we said that clusters represented here. The cluster represent the groups. Cluster represent the groups. Okay. Clusters represent the groups. Cluster represents the groups. For example, I have a data x-axis and y-axis. I have a data x-axis and y-axis. Here the two groups of data we have. Two groups of data. So group 1, it's a group 1 and it's a group 2. Okay, it's a group 1 and it's a group 2. Here in center, in the middle of these things, we have centroids. In the middle, we have a centroids. This is called centroids. It's a denoting of a main head, like a head of a group. Centroid is a middle value or a head of a group. Okay, middle value or head of a group. So, for example, how to make this k value? Like here, the k means cluster name. How to define this k value? By using elbow method. By using elbow method, we can easily identify the k value. We can easily identify the k value. Elbow method simply looks like elbow method. This is elbow, right? Where exactly the edge of elbow is bended, we consider that is a k value. We consider that is a k value. Whether it is 1, 2, 3, 4, 5, 6, 7. So we consider that where exactly the elbow is down, like bended condition, that is called a k value. That is called a k value. How can we find the centroids? Okay, where k is a centroids, right? K is a centroids. We are finding the k values each and every. If we k value is equals to 3, that means we have a 3 centroids. K value equals to 5, that means that we have a 5 centroids. 5 centroids means 5 groups we need to form the data. 5 groups we need to form the data. How can we find the k value? Okay, so find it. Steps. Step number 1. First, this is the k-means cluster algorithm working. Okay, this is the k-means cluster algorithm working. Step number 1, we need to try with different k values, with different k values. Okay, we need to try with different k values. This is a thing. After that, we will find which is the k value is best, which k value perform the most operation. So example, k value equals to 2. Example, k value equals to 2. Second step number 2. In step number 2, initialize initialize the k number of values. K number of values of centroids. K number of centroids. Initialize the k number of centroids. What is the k value? 2. That means we need to initialize 2 centroids. That means we need to form the 2 groups. We need to form the 2 groups. Step number 3. Step number 3. Calculate the distance between the each value. Calculate the distances between centroid and the points. Okay. We need to calculate the distance. This is a centroid, right? This is a centroid. We need to calculate the distance between these 2 point and centroid. For that, we need to use Euclidean distance. Calculate the distance by using Euclidean distance. By using Euclidean distance. What is the formula of Euclidean distance? Yesterday we already discussed about. What is the formula of Euclidean distance? Root of x2 minus x1 whole square into y2 minus y1 whole square. Right? By using this formula, we can easily identify the distance between the centroid and points. Okay, we can easily identify the distance between the centroid and points. Next, step number 4. Step number 4, computate the average. Computate the average of centroid. Computate the average of centroid and update. And update the centroid. Okay. So after finding the distances between each point and centroid, we need to count the average of a centroid and update the centroid. So whether the centroid move forward sometime or like this, we need to identify the things. Okay. This is all about your K-means cluster. The working formation is like this. So here, if you want to find the K value, I already told you, if you want to find the K value, we need to use the elbow method. Right? By using elbow method, we can easily identify the K value. By using elbow method, we can find the K values. Right? Understand? This is all about your K-means cluster. Unsupervised learning, we don't have that much of maths. You can explain up to you for the interview. Okay? Clear? Online clear? This is a K-means cluster. Next algorithm, we are going to discuss about next algorithm is hierarchical cluster. Hierarchical cluster. Okay, hierarchical clustering or clustering, both are same. Hierarchical cluster. Okay, so in hierarchical clustering, we need to somewhat different regarding to that. Here also the main theme is to identify the K centroids only. So this is my x-axis. This is my x-axis and my y-axis. So I have points like this: P1, P2, P3, P4, P5, P6, P7. Okay, I have points like this in my x-axis and y-axis. So to the hierarchical format, we need to find the dendrogram. Okay, we need to find the dendrogram. So for suppose example, consider 1, 2, 3, 4, 5, 6, 7 on y-axis. Okay, 7 on y-axis. These are the points. So on x-axis, I am taking P1, P2, P3, P4, P5, P6, and P7. Okay. for assumption. So which points are near to this? These are near, right? These are near. So I need to draw the some so and so example. I need to draw like this. Okay. I am connecting P1 and P2. Again, these points are too close. These points are too close. That's why I am taking so and so value P6 and P7. After that, these 2 points are too close. So value is P4 to P5. That's it. This point. After that, these two entire these two is related near, right? So that means I need to connect this and this. After that, entire system is near. This works like this. Understand? This is called a dentogram. Dentogram. This is called a dentogram. So here, how can we identify the K value means? So non-touching things. Like if we draw the horizontal line, then not to be touched another line. If we draw the horizontal line, it is touching to here, right? So again, if you draw the line, it will touch to here, right? So if you draw the line, it will won't touch for anyone. So this is a K value 1, 2, 3, 4. Where K equals to 4. Where K equals to 4. We need to pass the vertical line on the vertical line, one horizontal line. We need to pass the horizontal line on the vertical lines. So if the line is does not touch for the another lines, we consider that is a K value. We consider that's a K value. Clear? Clear? So this is all about the hierarchical cluster. Simple things. We don't have anything support it. But hierarchical cluster does not work for the huge amount of data because each and every data point need to be unlike and make a datagram. It is not possible. So there is a drawback of hierarchical cluster. Only the small amount of data only we use the hierarchical clusters. Okay, hierarchical cluster. Again, we are going to discuss about some of the things like how can we validate the whether the cluster is fine, good or not. So by using how can we find the whether the cluster is good or not? Okay, by using select score, how can we validate like a cluster like for the cluster is good or not? So by using select score, by using select score, we can find the algorithm of a cluster is good or not. Okay, here select score means how can we find the select score means simply a of I equals to a of I equals to a of I equals to 1 by mod of 3i into minus 1 belongs to the sorry, one second. Summation of I will j belongs to the this is a huge it's a big problem of I comma j. Yeah, it's a formula. ఇది ఎందుకు యూజ్ చేస్తారంటే మనం క్లస్టర్స్ క్రియేట్ చేశాక అవి కరెక్టా కాదా అని ఐడెంటిఫై కి యూజ్ చేస్తాం. యాక్యురసీ ఐడెంటిఫై చేస్తామా, యాక్యురసీ స్కోర్ చేస్తాము, సేమ్ లైక్ దట్ స్కూల్స్. సో డిఫాల్ట్ ఎలా క్యాలిక్యులేట్ చేస్తుందంటే ఇలా క్యాలిక్యులేట్ చేస్తాం. సో ఏఐ నెక్స్ట్ ఇంకొకటి కూడా దీంతో డి ఆఫ్ ఐ అనేది ఇంకో ఫార్ములా ఉంటుంది. సో ఇట్ ఈస్ ద డేటా పాయింట్ నెంబర్ 1, ఇట్ ఈస్ ద డేటా పాయింట్ 2. ఓకే, బి ఆఫ్ ఐ ఈక్వల్స్ టు మినిమం వాల్యూ 1 by mod of j pj summation of j belongs to jj and d of I. This is a form. So if you mix this, so let's go. S of I equals to d of I minus a of I whole divided by maximum value of a of I comma b of I if mod of Ci greater than 1. Mod of Ci greater than. This is a calculation how the Euler score is works. Okay, it works like this. First, we need to identify the Bi and Ai. Ai and Bi. After that, we need to find the third. Default it calculate like this. Okay, default will be calculated like this. So I'm in the clustering final algorithm in clusters final algorithm. DB scan clustering. DB scan clustering. So DB scan clustering means let me tell me the definition of DB scan. So DB scan means density base visual clustering of applications with noise. DB scan clustering. This is the definition of DB scan clustering. Density based visual clustering of application with the noise. Noise. Okay. This is the interview question. What is the expansion of DB scan? What is the expansion of DB scan? Density based visual cluster of application with the noise. What is expansion? DB scans. What is the expansion of DB scan? They will ask like this. Okay. Density based visual clustering of applications with the noise. SPATIAL. Sure. PIAL. Clustering of application with the noise. Okay. So in DB scan algorithm, we have 4 points. Point number 1 is so minimum point. Point number is minimum point. Point number 1 is minimum point. Point number 2 is core point. Third one, border point. Border points. Fourth one, noise point. So this is a minimum point is also known as a hyperparameter. Hyperparameters. If the DB scan works on the 4 points, not the types, it works on these 4 points. So okay, this is a sphere like a circuit. This is a circuit. This is a center. This is a called an epsilon. Okay. If a single circle of epsilon contain at least minimum of 4 points, it is called a hyperparameter. Okay, this core point is called a minimum point. So if same epsilon contain only 1 point, it is called a border. If any epsilon does not contain any points, it is called a noise. Noise. So the epsilon contain at least 4 points, that is known as a core point. This is all about your DB scan. In a single circle, the epsilon contain 4 points. It is known as a minimum point. Minimum 4 points is required. That is a point which, whereas the exact centroid is known as a core point. If any circle like a epsilon contain only 1 point, that is known as a border point. If there is no any values present in a epsilon, that is known as a noise. Nice. This is all about the theoretical information. This is all about the theoretical information of your unsupervised learning algorithms. So what is the definition? SVM. By the tomorrow. By the tomorrow close. On Monday. So let me move for some practical implementation. Let me show you. First. K-means cluster. Okay, let me show you the K-means cluster, how it exactly works. So this is the K-means cluster. It is a popular of unsupervised machine learning algorithm. It's breakdown into the clusters where the clusters is also known as the groups. We need to create the K-means, K number of groups. So before K-means cluster, it's our data. After K-means cluster, after applying the clusters of a group of a implementation, NumPy as NP, Pandas as PD. These are the common using the live data set type dataset where has the video status, everything. So shape info and is null dot sum. So drop the column 1, column 2 because we don't have column 1, column 2, column 3. So these are the NaN values. Simply I am dropping the NaN values. Simply dropping the NaN values. Enter data is in drop. So after that status unique. These are the unique status I have. And this is the length of the status, how many unique is around 693 members are present in the status. So these are the some of the basic analysis I have done on the status. So after that, extract independent and dependent variable. I convert the independent and dependent variable. So entire data need to be converted into the numeric. That's why I use the label encoder. Data is converted where x equals to x dot columns from the pre-processing mini scalar. If I use the mini scalar, entire data is converted between the standard zeros and ones. 0 and 1. It's a minimal normalization. Normalization. So I need to find the k value. Here this is the main important. I need to find the k value. From sklearn dot cluster import k means. From sklearn dot cluster equals k means. Cs equals to list, empty list. For I in the range of 1 to 11. For I in the range of 1 to 11. K means equals to k means dot n clusters equals to I. That is because n is stored here. Where init initializer equals to k means plus plus. It's a default thing you need to write. Maximum iteration equals to 300. Number of init is equals to 10. Random state equals to 0. Okay. K means dot fit the x value I need to the fit. CSE dot append. What are the k values initializers is came that need to be append to the CS step. So this is a range of things, and we finally here the k value 2, 3, 4. These are the three k values. So from the sklearn k values, first consider k means k cluster equals to 2. First, usually I am taking the k value equals to 2 and apply the concept. So this is the centroids of a 2 and initializer. And if you apply the labels of the data around and get in, this is the output like 0.6% of data. Again, where k equals to 3, same form. Just I am changing the values of k. K equals to 3. When I apply the k equals to 3, I get 0.59. 59%. Again, k equals to 5, I get 58%. Which is the best one? First one is the best one. That's why we prefer for the first one. Clear? That's fine. We prefer for the first one. Like that it works. So another DB scan. So DB scan cluster. Let me explain the same the DB scan cluster also. So we know like the dimensions visual cluster of applications. This is a DB scan cluster. So implementation of DB scan is very simple. Simply same importing the things. Here from sklearn dot cluster import DB scan. Everything in the caps. Everything in a caps. From sklearn pre-processing import standard scalar to minimize the data. So df equals to same mal customer dot csv. This is the data set. I don't have any null values in that. Directly I am applying x equals to this is the data set I need to take, and db equals to db scan epsilons. EPS means epsilon. That is 3 epsilons I required. Minimum samples is 4. Minimum sample is 4. Model equals to db dot fit x. Model equals to model labels dot models. These are labels and these are the values. If you identify the matrix, if you want to identify the matrix, simple, non-zero, like labels equals to blue. So this is a so let's go. False, false, false means that is negative. That is a score, like completely the labels into the Boolean format. So this is a select score. Minus 23%. So this algorithm prediction is very bad. Select score is minus. Algorithm prediction is very bad. That's why the select score is less. Where is hierarchical cluster? So this is a hierarchical cluster, right? This is a hierarchical cluster. So hierarchical cluster is a type of unsupervised learning algorithm technique of data mining task. So same, this is the type. Recently we done same like that. We need to do. Okay. So types of hierarchical clusters basically there is a two type, agichromatic and diversity. So agichromatic is works for the bottom to upper, like bottom top approach, whereas the diversity matrix approach for the top to down approach. Okay, this is the formula. So we can use anything like same model data set I have making. So this is the entire tile head. So x-axis equals to data or location of values. So this is the dendrogram. I'm drawing the dendrogram. Observe. Import scipy dot cluster dot hierarchy as a CSH3. Okay, dendrogram equals to CSH dot dendrogram. I need to pass the linkage of X and method is a word. Method is word. So this is the dendrogram of Euclidean distance. So if there is only 5 columns in this data, but the dendrogram looks like this. So that's why this is a negative impact. This is a negative for huge amount of data. Okay. From sklearn cluster, import agglomerate clustering. So HC equals to agglomerate clustering. Number of estimated cluster is 5. Infinity, like infinity means distance. I'm using Euclidean distance. Linkage equals to what? Okay, linkage equals to what? So predictions, these are the predictions of the data, and I'm visualizing the data. Because I take 5 clusters, right? Number of clusters 5. That's why you get a 5. That's why you get a 5. Understand? So this is all about your unsupervised machine learning algorithms.
So we could use visualization.
And visualization from that. Each and everything we have a visualization, we have an analysis. Clear? This is all about your unsupervised learning algorithm. We have discussed about linear regression, logistic regression, decision tree, random forest, XGBoost, Adobe Boost, null based, KMM, K-means cluster, hierarchical cluster, DB scan cluster, and final one we have a support vector mission. Tomorrow, by the end of the tomorrow, you will close the mission. So mission learning. Mission learning we have supervised and unsupervised. Unsupervised algorithms has been done. Supervised algorithm, one algorithm is pending. That is supervised. Support vector mission is another one. Tomorrow I will explain with the example. So from the tomorrow it will be done. By the tomorrow it will be done. Here, done. So that's it all for the machine learning. So on Monday, we are going to discuss about the deep learning also. Deep learning, Monday, Tuesday, Wednesday, Thursday. It's take around 3 to 4 days. After that, our next week, we are going to discuss about the natural language processing. That will be ended on next week. After the natural language processing, I don't know who are you, we don't know me. That's it. Tata, bye bye, see you. So guys, understand? So this is the concepts of unsupervised learning. If you don't have any doubts, you can leave the class. Thank you. Do the practice the things.